Long before humans ever walked the Earth, the planet's most isolated corners operated by an entirely different set of rules. Untouched by outside influence, these deep forests and distant islands were primordial Edens where strange biology was allowed to run wild. Look at the South Island of New Zealand. This stunning expanse of glacial rivers and golden valleys existed in a complete biological vacuum. There were no mammalian apex predators here, no lions, no wolves, and no big cats. In an isolated environment like this, the ecosystem acts as a massive pressure cooker. When a habitat is full of empty ecological niches, local species are forced to evolve at extreme speeds to fill them, resulting in shapes, sizes, and behaviors completely alien to the rest of the world. These animals dominated their respective islands, serving as highly specialized apex predators in worlds that no longer exist. This diagram shows how fast that evolution happens. On the left is the little eagle from Australia, a relatively small bird of prey. In less than 2 million years, it rapidly evolved into Haast's eagle, a 40-pound apex predator with a wingspan approaching 10 feet across. To hunt giant moa birds, this eagle developed 4-inch talons, roughly the size of a modern grizzly bear's claws. It even developed a pale, vulture-like bald head, a highly specific adaptation for plunging deep into the body cavities of giant carcasses to feed. Now let's look at an entirely different kind of isolation. Nearly 300 miles off the coast of Argentina, the Falkland Islands are a brutal, freezing, windspecked archipelago of rocky coastlines and rolling grasslands. When early explorers arrived, they were stunned to find a canine predator living completely alone on these remote rocks. The Falkland Islands Wolf baffled Charles Darwin in 1833. He could not fathom how a land predator ended up so far from the mainland. Trapped on these islands, the animal underwent insular dwarfism, a process where large animals shrink over generations to survive on limited resources. It evolved into a stocky, 2-foot-tall predator that scavenged along the beaches, surviving on ground-nesting geese, weak seal pups, and local penguins. Because these predators never faced any real competition, they ruled their respective islands with absolute authority. But that immense power was tied strictly to their isolation, leaving them highly vulnerable the moment a global apex species arrived on their shores. When an animal evolves for millions of years without any natural land predators to hunt it, it naturally loses something crucial to its survival: the biological instinct of fear. You can see the effects of this perfectly with the Caribbean monk seal. These massive marine predators evolved in incredibly calm, warm tropical waters. They lounged in massive colonies on sandy beaches across the Gulf of Mexico, living completely without land-based threats. When explorers and plantation owners arrived, they exploited this docility immediately. They could literally walk right into the middle of huge gatherings and slaughter the seals for oil and meat. The animals just stared at the hunters from the shoreline, entirely unaware they should flee. The Falkland Islands wolf exhibited the same dangerous docility. Sailors could hold out meat in one hand to lure the curious wolf in and kill it with a knife in the other. In a closed ecosystem, dropping the instinct to panic and run is a brilliant way to conserve precious energy. But the moment human beings step onto the beach, that highly efficient adaptation becomes an immediate death sentence. Physical adaptations can be equally deadly. In the swampy grasslands of central Thailand, Schomburgk steer evolved an astonishing set of massive, basket-like antlers that spread outward up to 35 inches across, carrying more than 30 separate points. These antlers were highly effective for visibility and mating in open swamps, but they made running through thick brush entirely impossible. If the deer tried to enter the dense jungle to hide, those sprawling antlers would instantly snag on vines and branches. This map illustrates what happened when Thailand massively expanded its rice farming in the late 1800s. The agricultural boom quickly consumed the open wetlands. During monsoon floods, rising water pushed the deer into small patches of raised ground, trapping them on tiny islands where hunters wiped out entire herds. The deer's own evolutionary design became a physical trap. When its required habitat vanished, its specialized antlers made survival in any other environment impossible. Sometimes humans don't even need to hunt an animal directly to completely eradicate it. This is a process known as secondary extinction, and it's precisely what doomed Haast's eagle. Around the 1200s, early human settlers reached New Zealand and rapidly cleared massive swaths of ancient forest with fire. They fiercely hunted the flightless moa birds, wiping them out within just a couple hundred years. Because the giant eagle relied entirely on those birds for survival, the sudden loss of its primary food source starved the species out of existence. You see a similar collapse across the enormous network of river corridors and Central Asian wetlands. This vast terrain was once dominated by the Caspian tiger, a massive, shaggy-coated predator that could weigh over 500 pounds. During the 1800s, the Russian Empire expanded deep into Central Asia. As human settlements and agriculture fragmented the tiger's critical hunting corridors, military units placed heavy bounties on tiger skins, resulting in dozens of cats being shot every single year along the rivers. Human expansion acts as an ecological wrecking ball, concurrently wiping out apex predators and the complex, interconnected food webs they depend on. This timeline chart highlights the stark contrast between the speed of biology and the speed of human history. Along the top, you see species slowly adapting and perfecting their forms over millions of years. But on the bottom axis, you see population levels of these highly specialized animals drop off to zero strictly within the last few centuries. Look at how steep these lines are. The moment human industry, agriculture, and expansion reached their borders, animals that took millions of years to evolve were completely eradicated within decades. Most of these disappearances were incredibly quiet. The Caribbean monk seal, for example, survived into the 1950s, but slipped away so silently that the scientific community didn't officially declare it extinct until 2008. Fortunately, modern science gives us tools our ancestors lacked. By extracting DNA from subfossils, ancient bones preserved in thick, oxygen-free anoxic mud, researchers can finally sequence the genetic codes of these lost creatures. History records the loss of these animals, but modern science allows us to reconstruct the specialized biological traits of the creatures we erased. In fact, studying this genetic material recently led to an astonishing discovery. DNA testing of the extinct Caspian tiger revealed that it is almost genetically identical to an apex predator that is very much alive today. The modern Siberian tiger is effectively the living biological twin of the lost Caspian tiger. Researchers now believe the two populations were originally connected across one continuous range before human expansion fragmented their habitats. Because of this direct genetic link, there are very real, ongoing discussions within the scientific community about reintroducing Siberian tigers into the wild river valleys of Central Asia, where the Caspian tiger once roamed. By transplanting these living tigers back into their historical range, we actually have a chance to reverse a historical extinction event and restore a broken ecosystem. Evolution spends millions of years refining complex biological systems for specific environments, yet human expansion can erase that history in a few generations. Today, we finally have the scientific tools to choose which of these lineages survive the Anthropocene.